Hi, section 7.3, the two-way analysis of variance. So this is an extension of one-way layout. So we have the one more factor. So this section have several patterns, and we start with the simplest one. Okay, so suppose that there are two factors to explain a real valued variable. So last time we only have one factor, for example, the fertilizer, to explain yield. But we now have the one more factor, which may be the cultivation of the plant. Okay, so now we have two factors. The one factor, for example, fertilizer, and the other factor, the type of cultivation, to explain the continuous x. Maybe the factor 1 have 3 levels and the factor 2 have 2 levels. So multiple levels. And the two-way analysis of variance tests the overall effect of each factor. So fertilizer affects the yield, and also the type of cultivation affects the yield. And two-way layout. So consider the simplest situation that we have m times n measurements xij, and I represents the first factor and j represents the second factor. So we have one observation each for each pair of ij. So one observation from each pair of the cultivation, the fertilizer and the cultivation. And the two-way layout assumes that xij, the yield, is equal to intercept plus the factor determined by the amount, the contribution determined by the first factor, ice level, and the contribution of the second factor, j's level, plus error term. And error is assumed to be normal, 0 sigma square. And if we have all alpha i's, for example, if I is equal to 1 to 3, and if we consider the alpha 1, alpha 2, alpha 3, that is redundant because suppose that we have 3 levels, then mu is the coefficient of the intercept. So if we think about the design matrix, model matrix, this is all ones. And if we think about alpha 1, alpha 2, alpha 3, so the indicator variable for the first level and the second level and the third level of the first factor, then vector becomes this. So in this case, the indicator variable for alpha 1 and alpha 2 and alpha 3, so summation of this becomes intercept. So one variable is redundant, so we have to remove the one of them. So one way is to assume alpha 1 is equal to 0 and beta 1 is equal to 0. So in this case, the mu represents the level for the first, the mu is the yield, baseline yield for the first level of the first factor and the first level of the second factor. So for example, the fertilizer 1 and the ground, the combination of these two. And yeah, so in such a case, for example, the alpha 2 means the difference between the level 1 and level 2 of the factor 1. So the difference between the fertilizer 1 and the fertilizer 2 on the yield. And another way to put the restriction is the summation of alpha 1 is equal to 0. So this effectively reduces the one parameter. And summation of beta j is also 0. So this is the definition of the two-way layout. Okay, so some notation. So xi dot bar. So this is the group mean of the ice level of the first factor. And x dot j bar. So this is the group mean of the j's level of the second factor. And x dot dot bar is the overall mean. Then we can define the sum of squared deviations. So first one is sum of squared deviation between group for the first factor. So basically this is SSDB for the first factor. And this is the n times summation, the I is equal to 1 to m, the xi dot bar minus x dot dot bar. So this is the difference in between the overall mean and the ice level. So this is the between variation for the first factor. And to make the overall the number of terms equal to m times n, that we multiply n here. And the SSD2 is defined in the same way. So this is basically the SSB2, sum of squared deviation for the between groups for the second factor. And that we define the quantity similarly. And SSD residual, the sum of squared deviation for residuals, is defined by the squared xij minus xi dot bar minus x dot j bar plus x dot dot bar. So the interpretation is here. So xij minus alpha I minus beta j minus mu is equal to epsilon ij. This is from the definition. And suppose that our restriction is summation of alpha I is equal to 0 and the summation of beta j is equal to 0. Then the mu is the overall level. So x bar dot dot. Basically, x bar dot dot is the estimate for mu. And alpha I is the difference between the ice level and the overall mean. So xi dot bar minus x dot dot bar. And beta j similarly. So if we plug in these numbers, estimates for alpha I, beta j, and mu, then that becomes xij minus alpha I dot bar minus the x dot j bar plus x dot dot bar. So basically, if we compare, for example, SSD1 and SSD residual, we can see the effect of the first factor. So now the testing scheme. So we want to test at first this null hypothesis against this alternative. So null hypothesis is the null model. Xij is intercept plus error. So basically the null model. And against the alternative. Alternative is the model including the intercept and the first factor, so alpha I. And alternative, of course, it's different from the null hypothesis. So that means the sum of alpha I is not equal to 0. And the second test is this null hypothesis against this alternative. So null hypothesis is the alternative of the previous one. So this text is a kind of sequential. And the alternative model has another parameter, another factor, the bj. So b sub j includes the several factors if we have multiple levels. So h1 is basically the beta j is still significant even if alpha I is already in the model. So this is a kind of the more strict, more conservative situation for the second factor. So second factor may be useful if first factor does not exist. But if first factor is really explained, the many of the xij, it's difficult to beta j to come in. So it's more difficult to reject the h naught for the second test, conceptually at least. So this means the order of the factor matters. So first one is alpha I or first one is beta j. So that matters. So alternative testing scheme is we include beta j here and we could include beta j here. And the second test is for alpha I. So this is alternative scheme. But actually, yeah, so in general, this order that should matter for the test. But if we have one observation for each pair of ij, then the test result is invariant when the order is changed. So if we use this test in red, that isn't different from the test in the other way around. So the effect of alpha I and the effect of beta j are interchangeable. So if we test the effect of beta j in the first test and the effect of alpha I in the second test, or the other way around, anyway, the effect of beta j, p-value for beta j are the same for both testing scheme. And the p-value for the effect of alpha i's are also the same for the two schemes. So that means the second test can be interpreted as this null hypothesis against this alternative hypothesis. So entirely the effects of alpha i's and the effect of beta j's are separated. And theorem. So basically we compare the relative size of the SSD1. This is the sum of squared the between groups for the factor 1 and the residual. So if this ratio is large, then that means the factor 1 is important. So if this statistic is large, then we reject null hypothesis. So reject H0 if this F1 statistic is larger than the sum threshold. And same test for the group 2. So SSD2 over SSD residual with some adjustment is larger than some value, then we reject null hypothesis. And the degrees of freedom corresponds to the number of levels. So in the previous slide, it's the same. And for the second factor, we have n levels. So the degrees of freedom is n minus 1. And the overall degrees of freedom for residuals is the m minus 1 times n minus 1. So this is the basic, the two-way ANOVA, the testing scheme. And finally, we have a table to summarize all of these. So at first, the factor predictor 1, factor 1 have m levels, and the factor 2 has n levels. And in total, m times n observations. Then degrees of freedom for predictor 1 or factor 1 is m minus 1, and factor 2 is n minus 1. And sum of squared residuals are here. And the mean squared residual is defined by SSD divided by degrees of freedom, so this. Then we can calculate this for residual also. And F statistic is the ratio between this number and this number. Then you can calculate p-value using the F distribution, the same for the second factor. So this is the summary of the two-way ANOVA.